All right, welcome back to another installment of trigonometry. So today we're going to look at 4.1 angles and angle measures. We talked about radian measure, and some important ideas here is that when we're dealing with degrees, the distance all the way around the circle in degrees is 360 degrees. Yet, when we are dealing with radians, the distance around the circle when we're in radians, pardon me, this is a rough start, is going to be, what's the distance around? Well, since it's on the unit circle, it has to be 2 pi. So those are kind of ideas that we have to consider here. So radian measure is quite nice, but we're going to have to get used to it. So we developed the unit circle and radians and the special angles. So today I'm going to start talking about coterminal angles. Now, a coterminal angle are angles that are standard position whose terminal arms are in the same location. So we're going to identify all terminal angles with 50 degrees. Well, I'm going to actually just start. And let's not be so ambitious as to get all the angles. I'm going to say one angle. Having a rough day. Angle. So I don't really know, but guess what I'm going to do? I'm going to draw my unit circle. I'm going to identify that point as being 50 degrees. So if that point is indeed 50 degrees, what is another angle that is coterminal that will have its same terminal arm? Well, very easy is, here's 50 degrees, right? What if I go 50 degrees and then I go another 360 degrees? So that would be coterminal. And if I go exactly one revolution, that is coterminal. So there it is. There's the idea of finding one. Now allow me to, by the way, that was degrees. Degrees was fairly straightforward. Now I'm going to go into this newly taught subject, radians. Suppose I have an angle that is in standard position and it's 2 pi over 3. So 2 pi over 3 is in quadrant number 3. It's in the pi over 3 family, fairly high up, is it not? So it's actually more up here than anything else, so maybe I'll just get rid of that stuff right here. Anyways, on the unit circle, if I have one angle that's 2 pi over 3, can you give me another angle that is coterminal with that? So I guess what I could do is an angle that is coterminal would be, you just simply add one revolution around, 2 pi. So really another angle that is coterminal. Now this is a little bit of fancy work here, no big deal. But another angle that is coterminal will be 8 pi over 3. Do we understand the meaning of coterminal maybe a little bit better, right? Coterminal angles are angles in standard position in which their terminal arms share the same location. And since their arms will share the same location, they will share the same sine, cosine, and tangent ratios, all of them. All right, let's get down to more serious business. I'm just going to erase this. I'm so sorry. Note some of it's not erasing here. Yikes, okay. It's like watching paint dry, is it not? All right, let's get started. I'm going to identify all angles that are coterminal. So really, it might be called a general type solution or something of the sort. All angles, wow, that's a pretty tall task. But so where am I going to start off? I'm going to draw my unit circle, and there's 50 degrees up there. So I'm just going to maybe expand this and concentrate only on 50 degrees. So I'm talking about 50 degrees. The next angle that I'm talking about, well, I'm going to do 50 degrees plus 360, right? One revolution. And then, okay, so allow me to show you what that means. That's 50 degrees here. That's one revolution. The next thing I'm going to do is, by the way, I'm not going to do the math on this. I'm just going to sit and watch it. And then I go another way around from that position. So that was 50 degrees plus 360, correct? And then I'm going to add another 360. All right. Now I'm going to get carried away. And then I'm going to have 50 degrees, and then I'm going to add one 360, and then I'm going to add a second 360, and you know what I'm going to do? I'm going to add another 360. Carry on. I'm always in the same position if I add 360. And then I get the clever notion that if I start off with 50, I could also subtract 360, right? And then I can go in the negative direction where I can say 50 degrees minus one 360, subtract another 360. So every time I add or subtract 360, it's just really a full revolution around the circle. So this is the idea in my head that I'm working around. So I'm going to start off by doing something really goofy. I'm going to say it's going to start off with the 50 here. And then I'm going to say plus 0 times 360, right? And then I'm going to add 0 360s. And then now this one here, I'm going to say it is 50 degrees plus, well, 360. But I'm going to do something weird, exactly 1 360 degrees. You probably know where I'm going with this, don't you? Now, I'm going to take this. Now, I've added 2 360, so I'm going to say, well, now this is going to be 50 plus 2 360s. And by the way, I can work inductively like this. That is just increasing the amount of rotations as I go up by intervals of 1. Exactly 1 revolution. However, let us not forget about this guy. So I can say, oh, yeah. And before, I could also subtract 360s. But I'm going to think of 50 minus 360 in a different way. I'm going to say 50 degrees plus, sorry, should be in black. I'm trying to make this really apparent to you. 50 degrees plus minus 1 360. Okay, yeah, you're working with me here. And I can actually do the same 50 degrees or plus negative 2 times 360. So there we have it. Have I described mathematically? No, this is very, very sloppy, right? Can I make a formula out of this? Sure I can. I think I could say 50 degrees plus like a variable. Now I'm going to call this variable k. $50 degrees plus k 360, right? I would like to make it -1, 0, 1, 2, etc., etc. However, what's really important now is k is element of the integers. We want the full revolutions to be in full integer amounts. Otherwise, our angles won't be coterminal. We will only get halfway around the circle instead of maybe exactly all the way around the circle. All right. Hope this helps. And let's maybe move on to radians. All right, there we are. Everything's erased. Good. You're probably at home yelling at the screen, there's an easier way to erase. Yeah, I don't really I'll figure that out for next lesson. All right. Now I'm going to identify all the coterminal angles to something that's written in radians. So now we need to switch our brains to think in radians, but where do we start? We start the exact same place. By the way, this position up here is 2 pi. So I'm going to identify positions that are coterminal with 2 pi. Me personally, I would argue that 2 pi over 3 is coterminal with 2 pi over 3. It's the same angle, but it does terminate in the same place. So I'm here, and then I'm going to find my first angle. Oh, I'm going to go exactly 1 revolution around the circle. So I'm going to say that is, here we go, we'll try that again. 2 pi over 3 plus 2 pi. That brings me to the exact same. Now, please, 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 it's important to be a little bit lazy. Don't try to simplify this, okay? And then I can go, well, wait a second. So that was 2 pi over 3. And what happened, I went exactly 1 way around the circle. That's what this describes. What if I go another way around the circle? Well, that's really 2 pi over 3 plus 2 pi plus 2 pi. Now, people would argue, oh, you should have wrote 4 pi. Sure, but it's harder to see the pattern. Now, I can do the same dot, 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 2 pi over 3 plus 2 pi, 2 pi, 2 pi. So I can simply do that in that manner. So what am I trying to do? I'm trying to create a formula. Now I'm going to look at this here. This is 2 pi over 3. Right here, this position here. Maybe I'm going to erase this. I would like to get in the same position. But if I subtract 2 pi, exactly 2 pi, I end up in the same position. Well, how about again, if I subtract 2 pi from that previous amount? Okay, this is ending up pretty sloppy. So I'm going to maybe consolidate my thoughts. Start off with 2 pi. And then my next coterminal angle is 2 pi over 3 plus 1. 2 pi, 1 full revolution. And then I can say it's 2 pi over 3 plus 2, another full revolution, dot, dot, dot. Now, as long as I go integral amounts of full revolutions, I should be okay. And by the way, if you want, you could write this plus 0 times 2 pi. And then you could write this here. We can also go in the negative direction, and that's 2 pi over 3 plus -1 times 2 pi. So again, we can make a nice little formula out of this, right? I can say all angles that are coterminal with 2 pi over 3 are 2 pi over 3 plus k times 2 pi. Where k is the numbers that I've highlighted in pink. K's are integer values. By the way, in my humble opinion, I don't know what my opinion counts for, Z is the symbol for integers. Sometimes you'll see it written as stylized I. All right, I hope that helps. Let's move on to the next slide.